I gotta figure out a way to grow 3 years worth of food here on a planet where nothing grows.
Even though Matt Damon is cute, and NASA scientists did fact-check parts of his movie's production, most of the technologies featured in The Martian aren't quite around yet. But those same scientists and engineers are now working on the technologies that Watney used to survive. The blanket term for these technologies that recycle planets' resources is in situ resource utilization. Harnessing the natural resources of planets would be essential to settling outer space. Electricity. Basically, when light hits a solar panel, it's shooting a ton of energy onto a layer of silicon doped up with phosphorus. Those electrons want to get out of there. They move up to a layer where there's more room for them, and they stream away and are collected and stored as electrical potential energy. So to maximize our energy outputs in deep space, scientists are working to perfect multi-junction solar cells. That way, we can harness as much of our solar system's sun's energy as possible. In 2020, NASA is sending a new rover to Mars, this time one with a special experimental unit on it called MOXIE, Mars Oxygen In Situ Resource Utilization Experiment. Because the Martian atmosphere is almost 96% carbon dioxide, and we plan on maybe living there someday, we need to figure out how to pull that dioxide out of the equation. Well, some people already did. MOXIE takes CO2 particles, pressurizes them, and runs them into a chamber with a cathode and an anode to electrochemically split them into carbon monoxide and oxygen gas. We can breathe that. The oxygen from MOXIE could not only help us live on the red planet, but help us to get off of it. But of course, we also need a fuel source. Rovers on Mars have shown small concentrations of methane and other suspiciously life-signaling organic molecules. But that probably isn't enough to haul us out into space. SpaceX is working on a way to take Mars's bountiful carbon dioxide, mine out its frozen water reserves, and heat and pressurize both together to create methane. Finally, if we realize that we can't lug 12-volt batteries, tanks of oxygen, and thousands of gallons in return fuel aboard the space shuttle, why would we pack a couple thousand bricks on the space shuttle? Bricks are heavy! And so is the steel and plastic in The Martian. I have beef with that part of the movie, and so do scientists at Northwestern University's Materials Science and Engineering labs. They formulated a way to create cement on Mars using just heated sulfur and Martian soil. And rather than make astronauts go outside and build their own homes, large-scale, interstellar habitat 3D printers are being developed by universities across the country. I built one, and it's so cute. Ready? By using things we already have on Mars, like sunlight, carbon dioxide, ice water, soil, and sulfur, we can finally colonize the red planet and learn to live on it as efficiently as possible. Something that we can hopefully do right this time.